Hello friends. So in NMR spectroscopy, a chemical equivalence and non-equivalence proton is the important concept, and today we are going to learn this concept in details. First of all, we must try to understand what exactly the equivalent protons and non-equivalent protons. Two atoms are chemically equivalent when they are related by symmetry operation. For example, rotational axis, plane of symmetry, center of inversion, and etc. etc. In addition to this, by normal molecular motion, for example, rotation of sigma bonds, ring flip, chair axial and equatorial position. Now we'll move ahead and we'll try to understand with the help of this simple example. Here you can see that this carbon is attached with these four different atoms. For example, first one is chlorine, another is chlorine, and here we have two hydrogens. For this molecule, C2 axis symmetry is there, and these two hydrogens are equivalent. So let us take the another example. Now here you can see that this is the benzene, and on benzene bromine is present. So bromine substituent is present. Now with respect to this molecule, if I draw this line like that, you will notice that this is the ortho hydrogen, this is also ortho hydrogen. So when we draw this line, at that time these two hydrogens become the equivalent hydrogens, and the hydrogens which are present at meta position with respect to this bromine are equivalent. So you can see here hydrogens with respect to ortho position as well as hydrogens with respect to meta position, they are equivalent, and the hydrogen which is at para position, this hydrogen, is totally different. So in this way, for this molecule we have three different types of protons. Now let us go ahead with another example. Now for this acetaldehyde, we have, just I will write this acetaldehyde like that. Now here total number of protons are 4. So these 3 as well as 4. In NMR spectroscopy, we have to find out how many sets of protons are there, how many sets of equivalent protons are there, and then according to that we get the number of signals. Here even though we have this 3 plus 1 means total number of proton is 4, but the hydrogen which are marked by a red color, they are equivalent. So this 3 hydrogen will become a one set, and this hydrogen, aldehydic hydrogen, is the another set. So 1 plus 1 is equal to 2. So even though we have 4 hydrogens in acetaldehyde, it gives only 2 signals in NMR spectroscopy. Similarly, just look towards this example. Now here you can see that on this benzene ring we have this CH3. So actually the structure is like that. Now here the hydrogens which are in blue color, they are all hydrogens are equivalent hydrogens, and which are in red color 1, 2, 3, 4, so they are equivalent hydrogens. So even though we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10 hydrogens, we have 2 sets of hydrogen, 2 sets of hydrogens. and in NMR we get 2 signals. So we must try to understand what exactly the chemical equivalence of the proton, and according to that we get the number of the signals. So 2 sets, 2 NMR signals. Now let us have one example related to magnetic and chemical equivalence. Here on this benzene we have different substituents like fluorine, then we have chlorine, chlorine and the chlorine. If you see this molecule at that time, these hydrogens which are marked over here, these 2 hydrogens are magnetically equivalent protons, and if you see these 2 hydrogens over here, these are chemically equivalent proton. So here we get only 1 NMR signal, and here also you get only 1 NMR signal. Now let us look towards these another examples. So in benzene we have 6 protons, and all these 6 protons are equivalent protons. So even though total number of protons are 6, but in NMR, H1 NMR, we get only 1 signal. So this is the effect of this equivalence proton. So instead of having the 6 proton, we get only 1 signal in NMR. Similarly, in case of acetone, this is the double bond. So we have 6 protons, but we get only 1 signal in acetone. So similarly, the another third example is pyruvate, and here also we get only 1 signal. So thank you so much for your patient listening.